Now we're going to move on to an example using the intermediate value theorem. So let's say we have a function y equals 0.3 x to the third minus 2x plus 1. We're going to use the intermediate value theorem to conclude that a value of x equals c occurs between the interval negative 2 and 2, for which f of c is exactly equal to 1. So first off, we have to make sure that f of 1 falls between f of negative 2 and f of 2. So f of negative 2 is equal to 0.3 negative 2 to the third minus 2 times negative 2 plus 1, which is equal to 2.6. And f of 2 is equal to negative 0.6. We're trying to find f of c find f of c that is equal to 1. So we know that f of negative 2 is less than 1, and 1 is less than f of 2. So now we know that we can use the intermediate value theorem because this function is also continuous between negative 2 and 2. So the next step is to find the value for which f of c is exactly equal to 1. So we're trying to find c, and in order to do this, we are going to plug in 1 for y. So we get an equation that looks like this. And from this equation, we get 3 zeros. So we get 0, positive 2.582, and negative 2.582. But remember, the intermediate value theorem only concludes that a value x equals c is between negative 2 and 2. So positive 2.582 and negative 2.582 are both outside the interval negative 2, 2. So we can't conclude anything based on the intermediate value theorem. So what we're left with is x equals 0. So now we know that x equals 0 corresponds to a value f of c that is exactly equal to 1 for our function here.